Okay. So this is your application of standard normal curve, question number 7. This whole warning part here, I'm actually just going to ignore that for right now, and we'll just focus on the problem. So I believe you have different numbers than I do. There's always a chance I randomly picked the same ones you did, but probably not. So what we have here is that we know in a certain school, the SAT scores over the past 5 years have been normally distributed with a mean of 1,520. So we're assuming that this is population data. So this is actually going to be a mu. So my mean is here. And we know that P30 is going to be 1,372. So what they mean by that is that if you remember that if I have a 30th percentile, 30% of the data that we're looking at, or people, or whatever it is going to be whatever the score is here. So usually using percentiles for scores. So that means if I have 1,300 and what was again 72 here, that this region here should represent 30% of my data. Or we'll say 0.3. All right. So the information we have is this. We know that there exists some sort of z-score out there. We know, like I said, we can do this with z-scores, but we know that somewhere out there that there exists a z-score. We don't know what that z-score is. That is a mystery for us, so we're going to leave this blank. Well, whatever that z-score is, it should represent 30% of my data. So there is some sort of number here that if my z-score is less than it, is going to represent 30% of my data. So remember, this is a probability. So if we go to the z-score calculator, remember, this is calculator.net. If you look that up, you just typed in z-score. Also, I have it linked in your Canvas. So what we need is this part here, because we're looking for the probability that we have a z-score that is less than something. So ignore that it has x's, just pay attention. It's probability and a less than probability. So we put in our 30, hit calculate, and what we get is that the z-score that represents that area is going, or represents anything less than that represents that area, is a negative 0.524. So what that's telling me here, get a different color so this pops, is that if I have a z-score that is less than negative 0.524, that represents 30% of my data. Yeah, let me turn this one off. Okay, so that's the whole part of the z-score, is that you're just being provided with a probability. You just need to go backwards and figure out what that z-score for that probability is. So this is something that we'd already had done in that in-class assignment. It's the second part here that's usually a little bit more of the struggle. So for the second part, let's go through a little bit of information here again. What we're looking for is we're going to use the information that we just gathered, meaning the score here, and we want to know what is the standard deviation of the population of SAT scores. So what we're looking for is sigma. So the information that we have is this. We know that we have a mean of 1,520. We know from here, just to add a little bit to this, that these z-scores are actually a standardization or a representation of some actual values, so X values, so actual SAT scores. So this area that was here, that we said was 30%, well, that 30% is just as long as we have a probability that X is less than 1,372. That's a probability that happening is 30%. That's equivalent of those z-scores. So we know that if we had an X, we also know that the associated z-score is going to be that, or that X of 1,372, its associated z-score is negative 0.524. So we're saying that the z-score version of just all this is this. So that'd be 0. The other one would just be the negative 0.524. So what we need is that sigma, and we have this one formula that's going to give us sigma, which is a z-score formula. Because this formula has an X, or sorry, has a Z, has the X, has a mu, which we all have up here. And I can use it to figure out what the sigma is. All right. Let me give myself a little bit of room here for this. We're going to make a nice little block. So I'm going to write that z-score down again. So we said that z-score is just your X minus your mean divided by your standard deviation. We want to solve this for sigma. So the first thing we're going to do is multiply both sides by sigma, which means we're going to get z times sigma equals X minus mu. We want to isolate that sigma, so now we're going to divide everything by the z-scores. And what we get is that sigma would be equal to X minus mu divided by z. So we did something very similar to this in that in-class assignment. That case, we were just trying to solve for X. So I gave you the way how to solve for X, so you just didn't have to keep solving for it. This one, I was going to kind of let you guys try to work on it on your own. If you get stuck, I'll tell you how to do this. So if you got stuck and you want to just figure out how do you find sigma, it's this formula right here. So we have our information. We know X is going to be 1,372. We know that mu is 1,520. And we know z is negative 0.524, 0.524, yes. I said that wrong for a second. If you put this in your calculator, make sure you put parentheses around the top, or it will not do your sigma correctly. You'll not get the correct sigma. But when I did this, let me bring up my calculator again. I got 282.443.7, and it kept going. And we are being asked to round to the nearest whole number. So we are going to say it's just going to be sigma is 282. The rest of this is going to be a lot easier. It's usually this part of finding sigma. Once we have sigma, the rest of this goes much quicker. So let me clear everything. We'll turn this on now. So we have our sigma. So what we're being asked to find now is for a normal distribution, was the z-score for the 95th percentile. So this is very similar to when we were figuring out P30. So we know this distribution is centered here. And I just need the z-score for it. Okay. So we're doing 95. So this whole shaded area should represent 95% of my data, and we know there's some sort of X value and SAT score is associated with it. So that also all translates into, if we standardize this is 0, and this is associated with some sort of Z-score, and 95% of my data is below it. So I always have to find Z-scores first. So once again, I'm trying to find a mystery Z-score in which all my Z-scores, 95% of them have to be less than the Z-score that I have. So once again, we have a probability and we're looking at a less than probability. Down just a little bit. So we're still using this part here. It's just instead of 30 now, we're going to have 95. And what we see is that the Z-score associated with that 95% is going to be 1.645. And you can always use these like little pictures here to make sure that you clicked on the right probability if you sketch it out. So we're seeing that we're looking at everything being filled into to the left of whatever the score is. Okay, so we have the Z-score now. Last part here is we just want to use this information to determine what the 95th percentile score would be. So what we're being asked for is find X. So we're figuring out what that 95th percentile is. And once again, we know Z-score is going to be X minus mu divided by sigma. And this one, when I had solved it for you before, I said that what you got here was that X was going to be equal to Z times sigma plus mu. So once again, we have mu. We have sigma. And here we have Z. So what X should be is 1.645 times the sigma of 282 plus our mu of 1,520. Sorry, got to put that one back in my calculator quick. So 1.645 times 282. Make sure there's not a rounding error problem here. I get that the score that represents my 95th percentile is going to be 1,983.89. So we have to round this to a whole number again. So what you should get is 1,984. So it gives you 84 or 85 in case this number was off. If you didn't round that to a whole number, that may have thrown off your calculations down here, just so you know why I did that. But that's quickly how you do question number 7. If you still have any more questions about it, let me know.